Hello, everybody. Welcome to episode 178 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike. That is Gavin and Fia and friends. Have you guys ever had anything die on you?
So many plants.
Lots of plants, for sure.
Plants, really?
And then, well, okay. Plants are hard.
What kind of plants are we talking about here?
Name it.
Cactus.
Yep. So many cactuses.
Really?
Yep.
Yeah.
Okay.
So, and it's ironic because, you'd think they'd be so low maintenance. But they're in fact too low maintenance, where I have overwatered several cacti because I'm like, okay, well, clearly, like, it's bone dry. It needs something. And nope, it did not. And died. I've
What
done
did
that
you
with
kill?
a number of succulents as well.
What did I kill?
Yeah.
I didn't kill anything, but we're going to talk about the death of something in just a second. No, it felt like though when so just last month, so a week ago today as we record this, I've talked about him before on the podcast, but I gave away my baby boy, a little foster dog, Cashew.
Oh, yay!
Cashew.
He found his forever home. I cried like a baby when it happened.
Oh.
And I'll tell anybody. I'm not ashamed even a little bit. I'll tell anybody about that. But the woman who adopted Cashew was very sweet and has sent me pictures and has made that quite a lot easier. So
I'm so
it is
happy
much
for
better
him.
than the time we had to put down my childhood dog. But yeah, nothing. There's no like physical like nothing has actually physically died at one point. But let's not beat around the bush, fellas. We got some news.
We do.
Yep.
So, episode 180, so in 1 month from this episode, will be the final episode of this podcast. Or at least final regularly scheduled, never say never. But we will not be continuing, doing, the regular bi-weekly upload that we've been doing for a long time now. There's a number of reasons for it. Mostly, it's just that it has become, at least for me, and you guys can speak for yourselves, at least for me, like, too samey for how my brain wants to live. If that makes sense.
Running out of things to talk about.
Well, it's not as much that, like, there's a bajillion different groups of animals that I could just throw at a dartboard and do that, not run out of that kind of content. But, and, I do enjoy writing the scripts for them because it makes me learn at least something about pretty much everything for each episode. But it's just become pretty repetitive for me and not where I've felt my, like, creative desires going is kind of the gist of it. And, if at some point in the past this had sort of taken off and we had started a Patreon that we've joked about a number of times, mostly Mike has joked about several times throughout the history of this show.
Not dead.
And, this had become like a side gig rather than just a hobby, perhaps that would have, like, motivated, spending more time, thinking of different ways to...
Perhaps it would have motivated Gavin. If we were getting, like, paid in American dollars, there's no way I would let you end this. But, like, what are you talking about?
Right.
Yeah, no. Guys, let's make it really clear here. This is, it's not like a crazy amount of work. It's a little bit of work. It's a lot more work for Gavin. We do it for free. We've done it for a while now. When we first started doing this, Gavin had, like, barely started dating the woman that is now the mother of his child.
Yeah.
Things change over the course of, 6 or 7 or however many years we've been doing this podcast. And that's okay. We've had a wonderful time doing it. And I think, all of our, listener out there, will understand where we're currently at.
Well said, Mike.
Yeah.
Yeah.
But yeah.
But we got 2 more episodes for you. I think we're gonna have a good time in the process. Yeah.
So today we're talking about the Pleistocene Epoch. That was the one thing. That's kind of how I've known we were gonna end for a while, and then even a while before I told Mike and Fia, which was at this point probably 2 months ago.
Mm-hmm.
but I knew for sure that I wanted to end our series of like all the different like sections of Earth's history.
Right.
And so today we're talking about the Pleistocene Epoch. Next episode we're talking about the Holocene Epoch, which is right now. And then in episode 180, we'll just kind of, the three of us just kind of talk about life and podcasting and what we've been doing since late 2020 here.
Yeah. It'll be a great reflection time.
Yeah. So hopefully you guys look forward to that and check out lots of other, great science education podcasts. There are a ton of them out there. And there will be some links to some ones that I recommend down below in the show notes of, the next few episodes. So with that is kind of our housekeeping for today. But as always, we have our Seagrass Corner and our Today in History. So Mike, what happened today in history?
So this episode is coming out April 1st.
Sure is.
Couple things about April 1st. So 2 years ago, April 1st, 2024, I got punched in the back of the head, and I've gotten headaches ever since. So
I don't mean to laugh, but that's not the kind of thing
true.
that I was expecting.
It's fun. It's like they sneak up on me at different times. It's like a fantastic, like, you never know, what's behind the corner.
Wow.
So that's number one.
It could be the fist of a child.
It absolutely could be the fist of a child. So yeah, that's number one. Number two, a lot of different things to go with here. We're gonna play a little game. Do I want to do geography, fast food, or presidents?
Fast food.
Or math.
Fast food.
I'm with fast food or presidents.
All right, we'll do fast food. Which really isn't fast food, actually, now that I think about it.
Oh my god.
All right, so April 1st, 1996, Taco Bell took out a full-page advertisement in 6 U.S. newspapers and said that they were purchasing what American landmark to reduce the country's debt?
What year?
1996.
Mount Rushmore?
Not Mount Rushmore. Thea, do you have a guess?
No.
Remember, it's Taco Bell.
Oh, the Liberty Bell.
The Liberty Bell. They put an advertisement in.
Or did they just say
purchase
they were
a Liberty Bell?
Okay.
Yeah, the Liberty Bell is not owned by the Taco Bell Corporation.
Well, right. That's why that's why I said Mount Rushmore. I've been to Mount Rushmore. I know it's not owned by Taco Bell.
Yes. No, this was a big. They were going to rename it the Taco Liberty Bell or the Liberty Taco Bell, whatever it is. And it was a wonderful advertising campaign that Taco Bell did. Yes, back at a time when things were fun,
and back when people cared about the debt to the extent that they were willing to do things about it.
Hey man, the 1990s, give Slick Willie and Congress some credit. We had a budget surplus in the 1990s.
And then we got into a war in the Middle East, and then that went away. Oops.
Good news, we learned our lesson.
Good news. Good news. Anyway.
Oh my god.
April 1st, you guys may be familiar, there's a holiday. So there you go.
Yeah.
Yeah.
I didn't even make that connection, I'm going to be honest, that Taco Bell was April Foolsing.
Yeah. Really? You had no idea?
I know that those dots did not connect in my brain.
That also did not connect.
I thought I said that, but I guess when I said April 1st, I was not clear that meant April Fools. So that's on me.
Well, I understood that.
Maybe this is why the podcast never took off. Maybe this is why we don't have a Patreon.
I understood that it was on April Fool's Day. I did not understand that they did it for April Fool's Day.
No, they just did it for some
That
giggles.
makes sense.
There's my one swear for the podcast.
That makes sense. Awesome. Well, thanks for that, Mike.
No problem. All right, Fia, tell me about some grass.
Yeah, so I got here very quickly, and I did not do a Seagrass Corner today, but I want to just quickly plug the webinar that I am co-guest starring in as part of my Seagrass Corner. And again, it's called Nature Coast Currents. Link in the show notes, but it's a webinar series that aims to communicate and catalog research in Florida's Nature Coast. It's about 30-40 minutes, Q&As, about coastal and marine science topics. They are free, and anyone is allowed to sign up for it. So next one is going to be April 15th. It's a Wednesday at 2 p.m. And it's by a researcher that I'm really kind of a fangirl of, Shelley Kruger, because she works with sponges, and she's going to talk about some sponge restoration, aquaculture in the Florida Keys. So if you're interested, check out the link in the show notes.
Yeah. And you will get one other reminder of that next episode, because that's actually the day the next episode goes out as well.
Perfect. Yeah.
Sweet.
Yeah. Awesome. Well, thank you for that, guys. So with that, let's get into talking about the Pleistocene. So the last episode that we did in this series was about the Pliocene, and I sort of subtitled that episode basically yesterday. This episode is actually yesterday. This is the slice of time right before the one that we are currently in. The Pleistocene also is colloquially referred to as the Ice Age. Very famously, had many movies about it, and they increasingly include lots of not Pleistocene animals.
Gavin, I need to ask another question, and here's the thing. I
Sure.
am like 80% sure I have asked this question before on the podcast.
Yeah.
And when you answer it this time, it's not going to stick in my brain again. So I just
Sure.
want you to know this is for nothing.
Okay.
But is there a difference between the Ice Age and Snowball Earth?
Yes.
Okay, what's the difference? That should be the same thing.
Well, okay, there's sort of like capital T, the Ice Age. That is this.
Okay.
Snowball Earth could be referring to a number of times. I'm also still a little sick, so sorry about that. A number of times when Earth had extremely widespread glaciers. So it's basically a difference in magnitude. So like during the Ice Age, as we'll get into, there were glaciers down to about, at least non-mountain glaciers. That will become important later. Non-mountain glaciers as far south as like 40 degrees, which is ballpark the border between Pennsylvania and Maryland. Still, that's a lot of glaciers. That's a lot of ice.
That's quite a bit of glaciers, yeah.
Snowball Earth is when basically everything except a couple degrees from the equator was, to varying degrees, solid ice or slush.
So just like a more of a snowball.
Right. And it's
More
like
of an
during
ice age.
the Pleistocene, snow or ice was pretty much restricted to the continents. Like obviously it can grow off of the continents. That's what like ice shelves in Antarctica are, where it's like the glacier extends a good ways off the continent itself. But like, at the North Pole, for example, there's no land at the North Pole. It's just ice.
Right.
Imagine that down to like 15 degrees from the equator latitude.
So that's significant. So
Yeah.
you said there's like capital T, capital I, capital A, the Ice Age, but it sounds like Snowball Earth is actually like the bigger thing.
Significantly more extreme.
Okay.
Yeah, and that's happened a couple of times, depending on exactly how you count it. Really only once, maybe, since there's been complex life swimming around.
Okay.
Yeah, so debatably some of the glaciations during the Devonian period, they got pretty far south. I wouldn't really call that a Snowball Earth. It wasn't like solid much. But for the most part, Snowball Earth mostly refers to some stuff like during the Precambrian, ballpark like 800. This is just off the dome, like 800 million years ago. And then there was an earlier one sometime over 1 billion years ago.
Okay. Yeah. And so we're not talking about any of that. We're talking
No.
about the Ice Age, which is a more mild version of this.
Yes, and we'll talk about.
Do they have the same causes?
Kind of. We'll talk about it.
All right, let's get into it. Stop listening to me.
Yeah.
So, the Pleistocene.
Right, I don't need to hear from you too.
the Pleistocene started 2.58 million years ago and ended just 11,700 years ago. Very recent. Like I said, actually genuinely yesterday as far as the Earth is concerned.
I wonder if there's people I could name from that long ago.
Nah.
No? You said 11,000?
11,700.
Nah.
This is pre-civilization.
We're talking like yeah. Close, but not quite there.
Yeah, like agriculture probably was a thing. Like more or less permanent settlements was more or less a thing. Sort of by the end. That's spoilers. That's kind of what changes from one to the other. But yeah, in episode 172, we talked about the Pleistocene Epoch, which was the one right before this. At the end of the Pleistocene, the world was getting much colder and lots of shifts were happening, both with life on Earth, but also all the abiotic parts of Earth. So let's start with that. First, right. North and South America reconnected via the Isthmus of Panama, which shut off several major ocean currents, which played a very large role in Earth's climate system. So that on its own would have done a lot of weird, funky stuff to the climate. If that was the only thing that changed, is that North and South America were touching again, that would be pretty dramatic by itself. But Antarctica was also continuing to expand its ice sheets, which also, by themselves, make the planet colder. Just having ice on the planet makes the whole world colder. Mostly because ice is very reflective. And any sunlight that hits, large ice sheets, a large portion of that reflects sunlight back out into space, which means that less heat from that light stays in the atmosphere, making it colder. So having a lot of ice makes it colder, which makes more ice, which makes it even colder, and now we have a positive feedback loop. And that's the kind of thing that happened in Snowball Earth. But there was
Which
a whole
lot. We're talking about today.
Yeah, not what we're talking about today. But that's the kind of thing. It's like there was a lot less buffers to sort of help mitigate that, because especially one of the first ones was before there was just barely photosynthetic bacteria at that time. So that's probably what triggered the first one, is that the photosynthetic bacteria started doing photosynthesis and sucked a whole bunch of carbon dioxide out of the atmosphere too fast, and that made it cold. And then that grew some ice, which made more ice, which made more ice, which froze the planet. That's basically how that happened from memory. But in the Pleistocene, there was life, significant life, which helps sort of buffer some of these extremes just through how like the chemistry and cycling of life works. We kind of touched on this in that episode 172, but there were some weird space cycles that we're kind of factoring in ways that I'm sure happened in older times than this. But because this is so recent, we have so much more data from the Pleistocene that we can actually quantify and, attribute things confidently to these various cycles of things in space. So, for example, Earth's climate is impacted by a number of, for lack of a better phrase, cosmic cycles that involve things like outputs of radiation from the sun. That kind of has a cyclical nature to it. The Earth's tilt relative to the sun. And several wind and ocean currents that are on kind of cycles that are affected by these other space cycles. And then lots of just earthly features that all kind of sync up with each other every now and then. If you want a bit of a more detailed explanation, go check out episode 172. We had a really good conversation about it there. But before the Pleistocene, Earth's climate was mostly on a 40,000-ish year cycle of low amplitude forces. So think of it like a sine wave. I know, Mike, you're not a math person, but are you aware of a sine wave?
I believe so. It goes up, it goes down, like
Yeah.
Yeah, okay.
But the peak and the valley are the same distance from the middle line, right?
Mm-hmm. Yes.
And so these cycles were relatively frequent. 40,000 years, as far as Earth is concerned, is instant. But they weren't very strong. The high points and the low points were pretty close together. Both in time, only about 20,000 years apart. That's how a cycle works, right? To get from the high to the low is half the time of the total. But the height difference, meaning in this case meaning temperatures, global average temperature, between the high point and the low point was not crazy. Like, it was there. It was measurable, but it wasn't insane. In the late Pliocene into the Pleistocene, so this is around that 2.5 million years ago, these various forces sort of started to change, and Earth's climate transitioned to being more influenced by a stronger 100,000 year-ish cycle. So the highs and lows were farther apart in time, about 50,000 years now from the high to the low, but they were much, much different in height. Which in this case, this sort of metaphor means temperature.
Mm-hmm.
And so the warm periods were much, much warmer than the cold periods. And there are obviously internal fluctuations within that. Think of it more like a set of stairs going up or down rather than a straight line, if that makes sense.
Mm-hmm.
And so this meant that things were generally pretty inconsistent, just globally. There's a really good graph that I'll have a link to down below that shows like inferred temperature changes from these cycles over the last 5 million years. So it's good just to get the frame of reference for like the before to how crazy the Pleistocene was.
Mm-hmm.
So at around 5 million years ago, in the early Pliocene, the difference between the high and the low was only about like 1 degree. Not a lot, right?
No.
In terms of global average temperature, that's significant, but not insane. And also keep in mind, this is not like summer versus winter. It's yearly average versus a yearly average a few thousand years later. So like 1 to 1.5 degrees difference.
Which doesn't sound like a lot.
It's significant, but it's not crazy.
Right.
When you get to the mid-Pleistocene, though, about 1 million years, the difference is between 6 and 9 degrees, depending on which cycle you're looking at.
Oh my gosh. I'm sorry, did you say
That is
Celsius or Fahrenheit?
Celsius.
Oh my god.
And this isn't like, there's no absolute temperature tied to this, it's all just like deltas. But the warm part of the cycle would have been global average temperature somewhere between 6 and 9 degrees warmer than the cold part of the cycle.
Wow.
That is absolutely enormous.
Yeah. I mean, yeah. I'm just trying to contextualize this. Like, there's like a big worry right now of like us trying to like keep 1.5 degrees Celsius change. Like,
I got bad news.
Yeah, I don't want to talk about it.
Yeah, and I did consider putting in something to that effect into this, but it's really comparing apples to oranges because the absolute change in temperature is not the worry with modern climate change, it's the rate, right?
Right, yes. And I'm saying
whereas
that
this would change between 6 and 9 degrees over the course of 50,000 years, whereas modern climate change is 1.5, 2 degrees over the course of 200 years.
Yeah.
So I did actually do the math. I didn't end up putting it in my notes, but this modern climate change is happening ballpark 100 times faster than this change.
That sounds bad.
Oh, it's real bad.
It sounds like someone should do something about that.
We really should.
Working on it.
Yeah. But yeah, So, 50,000 years. So again, that's the time difference between, peak warm to peak cold. That's not a lot of time, or vice versa, also. That's not a lot of time for life to adapt to such a significant change, right? But it's also, not so short of a time that life wouldn't have started adapting to it, if that makes sense.
Yeah.
But the kicker is that it didn't change quickly and then stay consistent. That would have been manageable enough, right? Instead, just the swings from cold to hot and back and forth. Life would start to adapt to the change, but before they could really get adjusted to the higher or lower temperatures, it would swing back. And, these cycles happened several times throughout the mid to late Pleistocene, and life was just generally not having a great time. But before we talk about life in more detail, let's talk about all that ice, because boy, there sure was a lot of it. At the glacial maximums, and they all kind of varied exactly how maximum they were, but this would be the coldest part of the cycles, you'd be getting like significant, Greenland, Antarctica-style glaciers as far south as places like Indianapolis, Cincinnati, Washington, D.C. D.C. itself was never actually glaciated, but that's at the same rough latitude as those other cities. And if you're in East
Coast... Is that because it's so close to the ocean?
Probably, yeah.
Okay.
But then again, I don't think it was the last glacial maximum, but it was one of them that formed Long Island, famously. Long Island is just a giant pile of sand that was brought down from Canada by the glaciers. So Long Island is where the glacier stopped and sat for a long time and just dumped a bunch of sand over, several thousand years. Yeah, that's why it's really hard to build on Long Island, because there's no rock there at all. It is just sand.
Hasn't stopped people from trying.
It sure hasn't. But yeah, so DC itself is kind of the rough latitude of how far south. Like, it would be like you just set foot on Antarctica, but you're at modern day DC.
Okay.
For example, also where I grew up in very northern New York, and similar case for central New York, with Mike and Fia are from. There would have been well over a mile of solid ice above us if you were standing on the ground.
Doesn't seem like it was very hospitable to Homo sapien life.
No. Well, in fact, we'll get to humans a lot later.
Okay.
But yeah, nothing, save for some bacteria and things, was really living in New York during these glacial maximums. And so, as we continue to talk about this ice, North America gets focused on a lot for the Pleistocene glaciations for a couple of reasons. Number one, I live here, so that's just what I've learned about most. Sorry. But also in Europe, they didn't get as far south, mostly because there's just not a lot of land mass as far north in Europe as there is in North America, especially like Western and Central Europe. Like, Canada is just kind of a runway for glacier formation. Just a lot of nice land for it to snow on, and then for the snow to build up, whereas you think of like Western Europe, and there's really just not much land, right? You get over toward, Eastern Europe and then into Asia, and then you just have like the giant, Russia. So Russia had a lot of glaciers, but there really weren't a ton in like France, for example, even though that's would have been glaciated latitude if it were North America. But there were some still in places like Norway, Finland, Sweden, and then Ireland and the UK were pretty much all covered as well. Antarctica already had them, just got bigger, which isn't really as interesting. Then in Asia, they expanded a lot, like I said, sort of in eastern Russia, like Siberia, basically. But made it all the way down into Mongolia and northern China. I haven't really heard as much about those glaciers. That's probably just a bias on a North American education. And then in places like South America, Africa, and Australia, they just really didn't have major glaciers, with a couple notable exceptions, mostly alpine glaciers, which are just glaciers in mountains. And it was so cold that mountain glaciers got much, much bigger than they are today. Broadly speaking, there are two different sort of kinds of glaciers. There's the kind that form ice sheets. That's what we have today in like Greenland, Antarctica, to a lesser extent Alaska and Siberia. These are the ones you like think about when you hear the word glacier. Then there are alpine glaciers that form in mountains because higher elevation means colder, and the ice can stay for the whole year round to build up and then form these constrained glaciers that flow down mountain valleys, basically. Mm-hmm. These are basically everywhere that there are mountains, as long as the mountains are pretty tall. For example, there are none in the Appalachians today because they just aren't tall enough. But there are some in like the northern Rockies. The Alps famously have quite a few. There are lots in the Himalayas and the Andes because they're very tall. And so on and so forth. But during the Pleistocene, during those glacial maximums, alpine glaciers would just expand tons, including places today that are known for their pretty hot weather. For example, thanks to the Rockies, there were alpine glaciers as far south as southern Mexico.
Wow.
Jeez.
And also, okay. Yeah, and also in large portions of every state that have part of the Rockies in the U.S., so like Arizona and New Mexico had a lot of glaciers in them just because a lot of the state is covered by the Rockies. Colorado basically almost entirely glaciated because the Rockies. The entire country of Turkey was almost entirely covered in glaciers. A lot of the Balkans, which are places like Greece, Croatia, Serbia, places like that, were glaciated as well. Basically all of Iran into Afghanistan and Pakistan. The Himalayas, which, very famously today have glaciers, they had glaciers that covered like the entire Tibetan Plateau, which is the area north of the Himalayas, which basically means like an entire third of China was glaciated from the Himalayas.
Wow.
This obviously would have had lots and lots of effects on like local climates, because not only did the glaciers get bigger, but they also got to lower elevations, and formed lakes and rivers and things in otherwise pretty dry places. Speaking of dry places, because so much water was being tied up in all of these glaciers, there's give or take a set fixed amount of water on Earth. Very small amounts, come and go from space, but for the most part, it's a pretty closed water system. So if there's a lot of solid water, that means there is less liquid water, and so ocean levels were really, really low. So much that a lot of places that nowadays are underwater were at this point dry land. Australia and Papua New Guinea were connected by land.
Whoa.
That's wild.
And they're not close. They are not that close together.
Yeah.
It looks like it if you look at it on a map from a North American perspective, but they are really far apart. And if you look at the animals that live there, that makes a lot of sense, because there's just a lot of animals that they share. If you remember, back to our monotremes episode, all of the echidnas, most species of echidnas live on Papua New Guinea, but there's a couple that live in Australia. Cassowaries, the giant flightless birds with like the helmet thing on their head, they live in Papua New Guinea and very northern Australia. Just a lot of crossover between the two. basically everything in the Indo-Pacific was connected. Places like Indonesia and Malaysia that today are made up of lots of islands were all connected, and were connected to the mainland of Vietnam, Thailand, Laos, Cambodia. Not the Philippines, though. Those guys have been islands for a really long time, it seems. Lots of things that today we call seas were land, just like basins. So the Caspian Sea, which is in Central Europe, the Persian Gulf, it's been talking a lot about in the news lately. Both of those were land. What?
I said, what do you mean, Gavin?
Well, that's where the Strait of Hormuz is.
I don't understand. What's the Strait of Hormuz? Can you please explain? I don't understand.
No. Moving on. The Korean Peninsula was not a peninsula, since the Yellow Sea that separates the Koreas from China was land. New Zealand's North and South Islands were connected. And all of this would have been somewhat transitory. During the bottom parts, the cold parts of the cycles, the land, the sea levels would have dropped and everything would have been connected. But then during the warmer parts, a lot of the ice would melt and those places would become islands and things again. So it's just a lot of sea level rise and fall in pretty quick successions. That being said, even as recently as 20,000 years ago or so, lots of places that today are pretty dry were not. The most famous example is that the Sahara Desert was really only this deserty on and off. The parts of the cycle when the glaciers were retreating, that just meant that there's a lot of extra water in the global atmosphere. During those times, the Sahara was much more like a savanna, much more like Lion King-esque, with grasses and trees, and was generally much more livable. And then when the glaciers would stop melting, during the peak of the warming phases, the Sahara would get very deserty like it is today. It's sometimes even larger than it is today. And that cycle continued for most of the back half of the Pleistocene. So that's kind of what the world was doing. There would be cycles where it would be a lot like today's global climate. And then 50,000 or so years later, it would be extremely cold. That does some weird things to life, so let's talk about that. Generally speaking, and sorry to say this, Fia, almost all of this, and almost all of the research as well, is focused on terrestrial life. Sorry.
Hooray! It's okay.
Yeah.
That means there's more research to be done.
Yeah, don't get me wrong. I'm sure that there are people researching it and that there is knowledge about this. It's just not what comes up when you don't get paid to do research about this. So,
fair.
But generally speaking, basically every animal that's around today was also around then. There's not a whole lot new between then and today. Some, but not a lot. There almost nothing you would see and be I have no idea what that is. Right?
Yeah.
The main exceptions is that there were lots of big mammals around back then that are extinct today. Throughout the Pleistocene, particularly in the late Pleistocene, there was a very sharp increase in extinctions that was heavily biased toward megafauna. Technically, I think it's over 100 pounds makes you a megafauna. But this was even more heavily focused on the really big things. Elephants, rhinos, stuff that size. And so for a good example of this, when people think of the Ice Age, probably the first animal that comes to mind is the woolly mammoth, right? At least that's what it is for me.
Mm-hmm.
However, there weren't just woolly mammoths. There were several species just of mammoth across mostly Eurasia and North America. I think there was maybe one species a little earlier than this in Africa. but there were also several species of mastodons, several gomphotheres, which we sort of colloquially call shovel-tusked elephants, a whole family of elephants called stegodons that had these like really long straight tusks that were really close together on the front, so their trunk had to like sit on top of them instead of being in between them. They're weird. And then even some species of like actual elephants in the elephant family that are all extinct today. Like today we only have 3 species of elephant, and they're all in the same family at the start of the Pleistocene, and then even throughout most of it, there were dozens of species of elephants that lived all over North America, Eurasia, and Africa, and even a bit into like northern South America as well. And they all went extinct except for the 3 we have today.
Wow.
Weirdly similar case for giraffes. Today we've got 4 species of giraffe that are in the same genus, and then 1 species of okapi, and they're all only found in Africa. During the Pleistocene, there were quite a few species all over Africa and Eurasia. And then also, as per usual, there were familiar animals in unfamiliar places, places where they don't live today. So like horses in the Americas, camels in North America. South America still has them. That's what like llamas and alpacas are. Like pantherine cats, which are the big ones, in North America and Europe, which they aren't anymore. Short-faced bears in North America, rhinos in Europe, stuff like that. And so a lot of this was just anything big toward the end of the Pleistocene kind of just went extinct. There's also, I forgot to put it in my notes, but I meant to. Australia had some weird stuff going on in that because it's a very large island, but it's technically still an island. And that does some weird evolution things sometimes. Australia had a number of giant reptiles during this time.
That sounds fun.
Yeah, so there were large terrestrial crocodilians. So, like, not hunting stuff in the water, but, like, chasing stuff.
Yeah.
Yeah.
Let's see. They had a species of giant monitor lizard, ballpark 50% or so, maybe bigger than Komodo dragons, that lives just on mainland Australia.
Well.
As well as one, like the last member of like a group of really weird turtle that had that were terrestrial, so like not even living in ponds and things, that had like club tails. But it was a turtle, and like weird spikes on its head and stuff. So Australia had some weird reptiles going on. And then New Zealand...
Some things never change.
Yeah. Well, I mean, they at least had big ones, which they don't really anymore. And then New Zealand and Madagascar had some weird bird stuff. They both had giant flightless birds. Like... imagine like an ostrich trying to do its best impression of an elephant. So like big flightless bird, but like much thicker, for lack of a better phrase, than an ostrich. As well as, so in Madagascar they're called elephant birds, and in New Zealand they're called moa. And in New Zealand there was also, to sort of go with this giant flightless bird, a giant flighted bird that hunted them. That was a giant eagle. That was the largest, like, eagle or eagle relative that we know of. That was enormous. Easily would, like, have hunted, like, medium children. Yeah, so there was a lot of stuff going on that I forgot to put in my notes that's really cool that I wanted to talk about, but I just forgot to actually phrase it well. But yeah, also during this time, lots of species followed a pattern in evolution and ecology called Bergmann's rule, which basically says in colder environments, animals get bigger. Being bigger decreases your surface area to volume ratio, meaning that you retain heat a lot better. you might have noticed your small friends get cold easier than your big friends. Same thing. This means that in colder places or during colder times, there were more or less just bigger versions of other species. Sometimes we see this just the same species where the populations are different sizes. A good example of this is brown bears in Alaska, which are quite a bit larger on average than brown bears in Yellowstone. Same species, but different places, so they're different sizes. Sometimes there were species that just dedicated themselves to being big. This was the case for some of the giant bears. There were a number of species of giant bear around at this time, but also things like cave lions, which were a good 10 to 20% bigger than modern lions. There were giant deer, giant ground sloths that were still around kicking at this time. And then even in places where there weren't widespread glaciers, like in Australia, there were giant kangaroos and giant wombat relatives. So, like, just because there weren't glaciers doesn't mean it wasn't colder in Australia, And the problem that all of these bigger things faced is that generally being big means you need more stuff. You need more space, you need more food, etc. And given the cycles of the glaciations, this meant that things get compoundingly harder as those cycles kind of continued.
Poundingly harder. Oh, we only got 2.5 more episodes left.
Yeah, I'll let you have it.
Thank you.
I'll even keep it in the edit.
What, do you normally take that stuff out?
Normally, no. Depending on what it is, I will occasionally. But
oh, I gotta start making more of these jokes.
Please don't. I mean, it actually makes less work for me to edit, so whatever. But yeah, so when the glaciers retreat, so when the glaciers, go back north, the animals follow them to, stay in their preferred habitat. And then, when the glaciers grow and move back south, that pushes all of them into a smaller area, meaning there's more competition, more predators, and just less ideal habitat in general. And then, after a bit of time in this high stress environment, the populations would have evened out a bit. The predators would have done their job and stuff. And then the glaciers retreat again and things open back up. But now, all of these populations, including the predators, have a pretty severe bottleneck. The populations would have been restarting from a smaller population, and this makes genetic diversity get weird, because you're growing a population from relatively few individuals, and so the genes that you have to work with are only what those guys have. And if your population's pretty small, that just means you're starting from a small sample size. And so they'd grow in population and then shrink and grow and shrink. And each time you shrink, you get rid of potentially any of the more different genes. And so over these cycles, these populations would just get less and less genetically diverse, which is not good. That is not a good thing to happen if you want your species to be successful.
Right.
Mostly in that what decreased genetic diversity does is that it makes your populations unable to resist change. Because, while some, for example, if a disease were to come through, if you have a big population, then some might just naturally be immune or more resistant to this disease. And then those ones are the ones that survive and go forward. But it's like, if this happens, if you have these multiple shrinks and grows, if the disease comes through, then everyone has pretty similar genetics, so everyone dies. And this also applies to, environmental changes, not just diseases and things, but if, at the start, your species had a variety of fur colors, for example, and then, each cycle, your species becomes more and more consistently one or two colors. If the environment changes to make those two colors make you stick out like a sore thumb, that's not good. So there's a lot of ways that these genetic bottlenecks can be dangerous for a species long term. And boy, was there a lot of big changes besides climate happening at this time as well. Mostly in that whenever you look into this extinction event, you always see two culprits mentioned in the same breath. Weird climate things and humans.
Those two things have anything to do with each other?
Not really at this point.
Okay.
Like maybe a little bit, but not given the context of today, no. But during the late Pleistocene is when humans made it substantially outside of Africa. Depending on exactly what evidence you're looking at, there might have been some kind of, human relatives in like the immediate close parts of Africa that are of like Eurasia that are right outside Africa. But for the most part, the mid to late Pleistocene is when humans spread around the globe. And by humans, I mean not just our species, but just human species around at the time, because there were a lot of them. And so, quick disclaimer for what's about to happen. I'm going to say, give or take, that X species of human was in a place Y number of years ago. It's going to be wrong. As we have talked about, we have a really good understanding of human evolution. We understand it really, really well. And so some people often argue about whether certain fossils are from one species of human to or another, because they're all really similar, and probably one evolved into the other or interbred with it, so it has some combined features, so it's really hard to tell. For example, if you, like me, go to the Wikipedia page for Neanderthals, you'll see that at the top it says that they evolved in the early part of the Middle Pleistocene, which is around 1.7 million years ago. That is much older than I had ever heard. And if you actually read the article, what they mean by that is that Neanderthal features start showing up in Homo heidelbergensis populations in Europe around that time. Where people draw the line between Homo heidelbergensis and Homo neanderthalensis varies depending on who you ask. Human evolution is a lot. Anyway, let's do a quick rundown of when various human species got different places. Homo erectus evolved in Africa around 2 million years ago and then quickly sprinted up to Eurasia and spread all around Eurasia. Homo antecessor was in Western Europe around 1.2 million years ago. The Denisovans, which are, if you don't know what the Denisovans are, look them up. They're very interesting. Technically, they don't have a genus species name because we only really know them from DNA. Partially from like DNA from fragmentary fossils, but also DNA from living people. We'll get to that later. The Denisovans were around Asia potentially as early as 1 million years ago. We don't have great fossils, like I said, so it's kind of hard to know. Homo floresiensis was on the island of Flores in Indonesia about 1 million years ago, and they got really small because they're on an island. That is a dwarf, like an island dwarfism species of human. They were only like 3 feet tall. Really interesting to look up. Homo heidelbergensis was in Europe around 700,000 years ago. Homo neanderthalensis, Neanderthals, were in Europe and Western Asia around 240,000 years ago. And then there's Homo sapiens. We evolved in Africa around 300,000 years ago. depending on exactly which evidence you look at, we got to the Middle East around 100,000 years ago, Central and East Asia around 70,000 years ago, Australia around 50,000, Central and Western Europe around 40,000, some of the islands on like the western side of the Pacific around 30,000, Central and North Asia, like basically Central Russia, around 25,000, Northern North America around 15,000, Central North America around 12,000, and then down into South America shortly after that. So, in the span of... Yeah, go ahead.
Are you... I'm just trying to make sure I understand. So, all of these different species of Homo, they didn't mix, right?
They very much did.
Oh, okay.
Not all of them, mixed with us, Homo sapiens, but a lot of them probably mixed with each other. And by 40,000 years ago, all of the other human species were either extinct or had been absorbed into Homo sapiens.
Okay.
For example, Neanderthals and Denisovans didn't so much go extinct in the traditional sense, as much as they interbred with us so thoroughly that they became part of us. If you are of European descent, you have a not huge, but substantial part of your DNA that is from Neanderthals.
Cool.
If you are of Asian descent, you have a decent part of your DNA that is Denisovan. So we just sort of, as Homo sapiens spread to these places where other human species were, we were like, that guy looks like me. I'm going to go have kids with him. And we did. And so, as humans marched around the world, not just Homo sapiens, but mostly Homo sapiens, with one sort of main notable exception, the local megafauna that were already not doing great because of these climate cycles just got demolished. Like, the climate stuff kind of set them up to not be doing well, and when Homo sapiens got there, that was just kind of the last nail in the coffin. And there's pretty good lines of evidence to support, a lot of times things are initially framed as binary, right? Was it the climate that did the extinction, or was it humans? It's never that simple. It's always some combination, right? But we have very clear evidence that, at least in some, humans played a part. We have lots of fossils with knife marks or arrowheads in them. Doesn't get a whole lot more obvious than that. The arrival of humans to a place usually coincides with the extinction of things there based on the fossil record. This would also explain the extreme size bias in the extinction. It is a lot easier to hunt big animals to extinction than small animals. Think about how hard it is to get mice out of your house. Or ants. It is really, really hard. I speak from experience. Not only there's a lot fewer of big animals just in a given area. The environment can only support, 4 elephants for every million mice, right? They're also so much easier to find. It's not hard to find an elephant versus finding a mouse, right?
Right.
Elephants are surprisingly sneaky and quiet, actually, but if they're on an open field, it's a lot easier to see them. And they also just reproduce very, very slowly. So they're easier to find, relatively easier to kill, and if you kill one, that is a significantly larger portion of the population than if you killed, like, a single mouse, right? And so one of the lines of evidence that I find most interesting for humans being the cause of these extinctions is that the places that had humans the longest seemed to fare the best. For example, Africa saw relatively little megafauna extinction. And that kind of makes sense. Because think about today, where you think of where the largest animals in the world live. Elephants, giraffes, rhinos, hippos. They live in Africa. Animals that had evolved for a few million years with human-like things might have been better adapted to this predator in their environment and better able to avoid being hunted to extinction by them.
Makes sense.
This is also true to a lesser extent in Central Asia. Humans were also there for a very long time, and there was less extinction there. And then you get to North America, where there had never been any species of human before. And that's where the extinction is by far the worst. However, like I said, it's never that simple. There's never one reason for an extinction. Humans generally didn't travel across large ice sheets. We would wait until the climate changed and then move there. It's hard to hunt stuff across ice because there's nothing there to hunt. And so the fact that humans got to a place inherently means that there was some locally weird, funky climate stuff going on that probably wasn't great for the animals. Things might not have been driven directly to extinction by humans. For example, some large herbivores were probably directly overhunted, but lots of things eat those herbivores, and now what are they supposed to eat? So the predators, might have went extinct because they effectively got out-competed by humans rather than hunted to extinction by them. And there are also lots of things that we have no evidence that humans hunted, at least no direct evidence. For example, here in North America, we have direct evidence of humans hunting mammoths, mastodons, gomphotheres, and bison. Those are the only things that we have direct evidence that humans hunted. At least at this time. But for all the different bears, horses, camels, saber-toothed cats, etc., they all went extinct too. And so, as with everything in science, it's complicated. And I really, really encourage you to look into this extinction if you are at all curious, because we have so much data about this one compared to all the other major extinctions that we've talked about on this podcast. I was just amazed at how much resolution the data has. Meaning the confidence intervals on it are shockingly small, which is good. And so there's just a lot of really interesting hypotheses that actually all have pretty good data around them. So if you're at all interested, even the Wikipedia page for this is pretty good. And then to end us off, and to set up our next episode, the last glacial maximum was about 20,000 years ago. And for the last 8 or so thousand years of the Pleistocene, things continued to get warmer. Homo sapiens, at this point the only remaining human species, continued to develop society. And that will be sort of the main focus of the episode.
Cool.
Mm-hmm.
That's going to be a weird one.
Yep, for sure.
And that's coming up in 2 weeks, right?
Absolutely.
Well, if you want to listen to what we have coming up in 2 weeks, you don't have much. I tell you, I was trying to do a whole thing about how we're ending the podcast. It didn't work. If I had time to workshop it, it would have been good. We have 2 episodes left if you want to listen to us. Well, I would say do it soon, but these podcasts are going to live on.
Right, it's not like they're
long
going
after. Yeah, they're going to be online. You'll be able to download them, but we will not be here very long. We've got a couple episodes left. You can catch us in 2 weeks for our penultimate episode. But until then, this has been episode 178 of I Wish You Were Dead, the podcast about things that used to be alive. We hope to see you guys in those 2 weeks. Until then, take care, everybody.
This episode of I Wish You Were Dead was written by Gavin Davidson and hosted by Gavin Davidson, Mike Bryson, and Fenella Campanino. It was sound edited and edited for YouTube by Gavin Davidson. Special thanks to former guests of the pod and to listeners like you.